Okay, we're going to finish up the notes from yesterday. This is 1.6 part 2. Yesterday we did by hand. We've had some data. We need to find a regression line or best fit line. We need to get the equation, get a graph it, make a prediction. Now we're going to do that with the calculator. So the example, find a regression line. Basically, it's another name for a best fit line when using technology. And I say using technology because we could do this by hand. It's called the least squares method, but it is a lengthy calculation. It's not very efficient to do it by hand anymore, so we use technology. We're going to use the graphing calculator for the data that we used yesterday. So this is the exact same data. So if you don't want to copy it down, you already have a copy of it from yesterday. There it is. It should be the exact same data as yesterday. So we're going to do everything with the graphing calculator. So here we go. Here's the graphing calculator. And obviously, we've got to turn it on. But who knows who had your calculator last or who is using it. So we need to clear some things out. So let's go ahead, wherever you're at, let's get back to the home screen. We do that by hitting second click. Okay, second click. Once you're on the home screen, we're going to clear this out. Let's just hit clear. So there's nothing on it. So everybody's at the same start. Okay? Now we need to put the data into our calculator. So we're going to go to the stat button. Stat button is at the top, 3 over, 1 down. S-T-A-T, stat. And we're going to be using edit and 1 to the right, the calculate menu. We're not going to use the test menu for this. Okay, so edit and calculate. Specifically, we're going to edit. So we're going to hit enter on edit. Now I already have some data in my calculator. You may as well. I don't know who used the calculator last, so I wouldn't trust them. So we're going to clear out these lists. And I stress the word clear. Okay, so go to the left and go up until L1 is highlighted. And then you're going to push clear, not delete. Clear the list. And then push down. And the list looks clear. Okay, let me show you what happens if you delete, because you might do it by accident. I'm going to go up to list 2, and I'm going to push delete by accident. And there it goes. It's gone. The list disappears. It's gone. I needed that list. So how do I get it back? We hit stat. Then we go down, number 5, setup editor. The setup editor will bring back all the default lists. So if you hit enter on that, hit enter one more time, then go to stat, edit, list 2 is back. Or if you were missing any list to begin with, they should all be back now. List 1 through 6. So I'll do it properly this time. Keep the cursor on L2, push clear, and push down. Data's gone. Now we need to enter the data. So under list 1, we're going to put the years. Remember yesterday, okay, sorry about that. Let's scroll back up. Remember yesterday, we said that X is the years since 1990. So instead of putting 1995 in for my list 1, we're going to put in 5. So go ahead and type in your list. 5, 6, 7, 8, 9, 10, 11, 12, and 13. I know you want to get the lists in there as quick as possible, but you need to be careful about typing. You mistype one number, and your graph's going to be off, your equation's going to be off, your prediction's going to be off. Okay? Now, this list was pretty simple. The next one, though, not so simple. List 2 is the corresponding value. So for 5, 12,811. I take a double check every time I type a number in. You know, I'm just not going to type it, just type. Take a look, make sure you typed it in right. 12,975. Because you could mix up numbers, you could miskey a number. Maybe you thought you hit a button and it just didn't show up. Okay? Taking 10 seconds now to make sure that these numbers are correct is going to save you a lot of problems later. Is that right? That one's not. So I'm going to go back. 13, 3, 6, 2. Okay, so the 3 got stuck or something. And even as careful as you may have been typing it in, I'd still go back up through my list and just double check one more time just to make sure that all the data matches up correctly. I didn't type anything in there. Also, at the end of your list, make sure that it matches. They should stop at the same place. Okay, if you have a long list of numbers, you may forget to enter one in. Or maybe there's a repeat and you didn't type it in twice. They should always end at the same place. All right, this looks good. So let's go ahead and graph it. Let's go to y equals. The first thing you do before you graph any data is you go to y equals and you look to see if there's anything in there that was left over, because this might not be useful. So I'm going to clear out any equations that I have in y equals. y1 all the way down to y0 and check, because you don't know who had what last time. Also, notice the plots at the top. One of mine is darkened. Okay? If a plot is darkened, that means it's currently turned on. Okay? If you didn't turn it on, you might not want it turned on. So how do we turn it off? Okay? Go up and hit enter on it, and that will undarken the plot. So that plot is now turned off. All of the plots should be off. So clear out the y equals, clear out the plots. Once you've done that, second y equals allows us to go into stat. That's where we're going to graph our data. Now we're going to hit enter on plot 1, and we're going to turn plot 1 on, because we want it on. Now we need to pick a type. The first type is scatter plot. That's what we want. So hopefully that's done. I'm going to run through the rest real quick just so you know what they are. This is a scatter plot with the data connected with a line. You might use that like a business presentation, some kind of chart. Third's a histogram. Fourth is a box and whisker with outliers. The fifth is a box and whisker without outliers. And the last is a frequency distribution. So really, for us, only the first one will be X list minus list 1. If you didn't type it into 1 and 2, you might pick another list. If it's in 3 and 4, you need to put 3 and 4 here. My list is L1 and L2. The mark, I would highly suggest you pick the first or second. The third one is very difficult to see. Okay? So once you have all that, we're going to hit zoom, which is the very top in the center. And you're going to go down to the number 9 zoom. It's a zoom stat. What zoom stat does is that it fits the window to your data. So you don't have to go looking for it. Go ahead and hit enter. And there's our graph, which looks very similar to the one we did back here yesterday. All right, we have a graph. That was the first part. Next part, I believe we had to draw a line. On the calculator, we have to go slightly out of order. We can't draw a line on the calculator without having the equation first. So we're actually going to calculate the equation. So we're going to go back to step. And we're going to go over to calculate. We have a lot of choices here. The problem said that we're supposed to do a regression line. Number 4, linear regression. It's of the form ax plus b. Well, if a is m, that's our slope-intercept point, right? Y equals mx plus b. So this is what we want to choose, number 4. Now, at the end of this, we should specify what lists we use. So second number 1 is list 1, and then you're going to hit the comma. Comma's right above the number 7, and then second number 2. Hit enter. Now, if you don't have the r squared value, r and r squared, here's how you get this. You're going to hit second 0, which is the catalog. We're going to go down to diagnostic on. So we're going to go down into the D's. Okay, there's a diagnostic on and a diagnostic off. We want to turn the diagnostic on. So choose that, push enter, and push enter a second time till it says done. Once it's done, the R should be there. So let's run through it again. Stat, calc, number 4, list 1, list 2. So what do we get from this? Well, we get our equation. Y equals 207 x plus 11,640. That's what we want. That's good. And then we get R, which is called the correlation coefficient. And we get R squared, which is the coefficient of determination. Now, R squared is going to be there for every single regression you do. I don't care what it is. If it's a higher level polynomial, if it's a higher level function, exponential, logistic, sinusoidal, quadratic, cubic, quartic, you're going to have R squared. R, you're only going to see with the linear. Okay? R is the one we're going to pay attention to for the linear regression. R tells us two things. How good of a relationship our data has, and what direction the graph is. So it tells us is it a good relationship, is it a bad relationship, in what direction. So the R value for this is 0.952, and I like to think of it as a percentage, 95.2%. Now R can be between -1 and 1. I think of it as percentage. Negative 100%, negative 100% to 100%. Now, the closer to positive or negative 100% is a good relationship. You want 100%, right? If you take a test, you want 100%. So this is a good relationship. We have 95.2%. That's nice. That's good. They're getting along. Okay? Because it's positive, we know what direction the graph is. Positive graph means it's going up from left to right. It's a negative graph, it's going down from left to right. Again, if you think business presentations, you're in sales, you want a positive correlation. Sales are going up. Now going down, you might want to change what you're doing. Okay? So this is good. We have an equation. Let's graph it. Okay? Y equals. Now we can just manually type this in. I'm going to scroll back up to my equation. Right there it is. 207 x plus 11640. Now I'm going to hit graph. this line runs straight through it, very close to the line we drew. Okay? Notice how close the data is to the line. That's going to tell us we have that strong positive correlation. Okay? So even though we might not have the line, or we don't have the data, if we have a graph that has data that's closely compacted and going up from left to right, we can make the statement that that is a strong positive correlation. What if we had this graph? We have very tightly compacted data going down from left to right. Okay? That's right. This is a strong negative correlation. Ours is definitely strong positive. We also could have something like this. Now this starts to get almost like an opinion, because is this strong? Is this weak? I would say it's a weak correlation. So we're going to call this a weak positive correlation. Once the data starts getting away from the line, starting to weaken, okay? It's not as strong as of a relationship as it was. All right? And we can do the same thing with the negative. It has direction, doesn't it? Does it look like it's kind of pointing down? It's not very definitive, but it is going down from left to right. So we'll call that a weak negative correlation. Then we have the last one. Can you tell what direction that's going? Absolutely not. You will call this little or no correlation. Now, realistically, 99% of the time, it's going to be little correlation. Because in order to have none, zero correlation, absolutely no relationship whatsoever, it would have to be absolutely perfectly placed. Okay, in order to have that. That'd be perfectly placed away from each other. So 99.9% of the time, we're going to have little correlation, 0.01%. But it's still some correlation. Very, very, very little, but there is some type of correlation. Okay, so that's something that you can see, you know, on the test. Picture and say what type of correlation is that. Okay. So we have a strong positive, line looks good. All we have left is to make a prediction, right? So two ways we can do that. One, we can just type it in. So we could just say our equation is y equals 207x plus 11,640. If you forget what it is, you can go to y equals 207x. And we're going to just plug in 20 for x, just like we did by hand, and we'll get an answer. So 207 times 20 plus 11,640. And we get 15,780. So that's the tuition cost for 2010. A little lower than our by hand guess. Again, it's a guess. We don't know what it's going to be. Okay. When we had the data, we could actually check 2010. We knew what college it was. But if it was like for 2020, we wouldn't know until then. So it's a best guess. There's one other way you can get that answer. If you go back to the graph, you can actually get the answer from the graph without doing any work by hand. Okay, so we hit second trace. Again, right beside the graph button, we hit the calculate menu. And we can calculate a value, number 1. And it says, what X value do you want to check? I want to check 20. And I hit enter. And it says you have an error, which is good, because you need to know what errors cause what. Why are we getting an error? Okay, it says invalid. What's invalid? Well, let's push the window button. Right beside the y equals at the top is the window button. And the window tells us how far left and right we can see on the screen. X min, X max. So the left side is 4.2, the right side is 13.8. The y min and y max tells you what the bottom and top of the screen is. Here's the bad part about the calculator. It can only calculate what it sees. Can it currently see 20? No. It is not. 20 is not between 4 and 13. So we have to put the screen up to a number that the calculator can see 20. So I'm just going to make the X max 25. Now it should be able to see 20. Do not hit zoom. Just hit graph. Now, we might not be able to see the point, but the calculator can now calculate. So, second trace, number 1 value, and we want the value at 20. And you can see 15,780 is right there on the screen. Same thing you did by hand. Your choice. Okay. So that's all I have for you today. That's the end of 1.6 part 2.